Mars, the red planet. Known for its striking red hue, this planet has fascinated humans for centuries. Its surface, covered in iron oxide, gives it that distinctive rusty color, making it stand out in our night sky. Today it's a cold, dry desert, a world of rusty red dust and ancient silent volcanoes. The landscape is harsh and unforgiving, with temperatures plummeting to extreme lows and dust storms that can engulf the entire planet. But it wasn't always this way. Mars has undergone dramatic changes over billions of years. From a potentially habitable world to the barren landscape we see today, its transformation is a story written in its rocks and valleys. Billions of years ago, Mars may have looked very different. Scientists believe that ancient Mars had vast oceans, flowing rivers and large lakes. These water bodies could have created environments suitable for life. Imagine, if you will, a younger Mars, a planet teeming with water, where rivers carved valleys and lakes dotted the landscape. The atmosphere was thicker, providing warmth and protection from the harsh solar radiation. This Mars had rivers flowing with liquid water, lakes that shimmered beneath a thicker atmosphere, and perhaps even a blue sky. The presence of water is crucial because it is one of the key ingredients for life as we know it. Scientists believe early Mars was warmer and wetter, more similar to early Earth. This similarity raises intriguing questions about the potential for life. If life could arise on Earth, could it have also emerged on Mars? This period holds clues to the question, was there ever life on Mars? By studying the ancient terrain and geological features, scientists hope to uncover evidence that could answer this profound question. Though Mars is a harsh environment today, the possibility of ancient life, even microbial life, is a tantalizing thought. Microbes could have thrived in the wet and warm conditions of early Mars, leaving behind traces that we might still find today. Finding evidence of past life on Mars would revolutionize our understanding of life in the universe. It would suggest that life is not unique to Earth and could exist elsewhere, waiting to be discovered. The search continues, driven by our unending curiosity and the hope of finding answers to one of humanity's greatest questions. So, what happened to transform Mars from a potentially habitable world to the desolate landscape we see today? The answer lies in the Martian atmosphere. Mars lost its magnetic field, which once acted as a shield, protecting its atmosphere from the solar wind. The solar wind, a stream of charged particles from the sun, stripped away the Martian atmosphere over millions of years. As the atmosphere thinned, Mars grew colder. Without a thick atmosphere to trap heat, temperatures plummeted. Liquid water on the surface evaporated, froze beneath the surface, or escaped into space. The once flowing rivers and lakes dwindled, leaving behind the dry riverbeds and empty lake basins we observe today. Although liquid water is scarce on Mars today, it's not entirely gone. The Martian landscape, with its dry and dusty terrain, tells a story of a planet that once had flowing rivers and vast lakes. Scientists have long been fascinated by the red planet's potential to harbor water, and recent discoveries have only deepened this intrigue. Vast reserves of water ice exist beneath the surface, locked away as permafrost. This permafrost is a frozen layer of soil that contains water ice, and it stretches across much of the Martian landscape. The presence of this ice suggests that Mars was once a much wetter planet with conditions that could have supported life. At the Martian poles, massive ice caps stand as testament to the planet's watery past. These polar ice caps are composed primarily of water ice, but they also contain frozen carbon dioxide or dry ice. The sheer size and volume of these ice caps indicate that Mars has a significant amount of water stored in its polar regions. These ice caps, composed of both water ice and frozen carbon dioxide, shrink and grow with the changing Martian seasons. During the Martian summer, some of the ice sublimates, turning directly from a solid to a gas, and then refreezes during the winter. This seasonal cycle is a dynamic process that continually reshapes the polar landscapes. Occasionally, even today, faint traces of liquid water might flow on the surface. These rare occurrences are thought to be the result of briny water, which has a lower freezing point than pure water, seeping out from underground sources. This briny water could potentially support microbial life, making it a key focus of astrobiological research. These flows, called recurring slope lineae, appear as dark streaks on Martian slopes during warmer periods. They are one of the most intriguing features on Mars, as they suggest the presence of liquid water in the recent past. The exact mechanism behind these flows is still a topic of scientific debate, but they remain a tantalizing clue in the search for water on Mars. While their exact nature is still debated, they offer a glimmer of hope that liquid water, even if transient, might still exist on Mars. The possibility of liquid water on Mars has profound implications for our understanding of the planet's history and its potential to support life. As we continue to explore Mars, each new discovery brings us closer to unraveling the mysteries of this enigmatic world. Mars may no longer be the watery world of its past, but it remains a fascinating planet of extremes. This red planet, our closest neighbor in the solar system, has captivated human imagination for centuries. From its towering volcanoes to its deep canyons, Mars presents a landscape that is both alien and strangely familiar. The Martian day, called a sol, is only slightly longer than an Earth day, lasting about 24 hours and 39 minutes. This means that if you were to spend a day on Mars, it would feel almost like a day on Earth, just a bit longer. However, a Martian year is nearly twice as long, taking about 687 Earth days to complete one orbit around the Sun. This extended year means that seasons on Mars last much longer than those on Earth. Temperatures on Mars swing wildly, creating a world of extremes. The thin atmosphere, composed mostly of carbon dioxide, offers little insulation, leading to drastic temperature changes. At the equator, temperatures can reach a relatively balmy 70 degrees Fahrenheit during the day, making it one of the warmest places on the planet. But as night falls, or if you travel towards the poles, you would experience a frigid -200 degrees Fahrenheit. These extreme temperatures make Mars a challenging environment for both human explorers and robotic missions. Mars is home to the largest volcanoes and canyons in our solar system. These geological features tell a story of a planet that was once geologically active. Olympus Mons, a shield volcano 3 times taller than Mount Everest, dominates the Martian landscape. Its sheer size is a testament to the volcanic activity that once shaped the planet. Valles Marineris, a system of canyons that dwarfs the Grand Canyon, stretches across a significant portion of the planet. This vast canyon system is over 2,500 miles long, up to 120 miles wide, and as much as 4 miles deep. These features, along with the planet's dusty red surface and thin atmosphere, make Mars a world of extremes, a place of both beauty and danger, and a prime candidate for future exploration. Section 5, Scars of the Past, Volcanoes and Canyons. These immense geological features, formed over billions of years, tell a story of Mars's dynamic past. Olympus Mons, with its gently sloping sides, formed from lava flows that erupted over eons. Valles Marineris, a testament to tectonic forces likely formed as the Martian crust stretched and fractured. These features, preserved in the dry Martian environment, offer a window into the planet's internal structure and geological processes. By studying these features, scientists can piece together the history of Mars and learn more about how rocky planets like Earth and Mars evolve over time. Section 6, Robots on Mars, Exploring the Red Planet. For decades, robotic explorers have been our eyes and ears on Mars, venturing across the planet's surface and sending back invaluable data. From the early Mars landers like Viking 1 and 2, to the rovers like Sojourner, Spirit, Opportunity and Curiosity, each mission has added to our understanding of this enigmatic world. These robotic pioneers have analyzed Martian soil, studied rock formations, and searched for signs of past or present life. They've sent back breathtaking images of Martian landscapes, from vast plains to towering mountains, revealing the beauty and desolation of this alien world. Section 7. The Search for Life, Past, Present and Future. The search for life on Mars is a driving force behind our exploration of the Red Planet. While no definitive evidence of past or present life has been found, the possibility remains tantalizing. The presence of organic molecules, the building blocks of life, detected by the Curiosity rover, further fuels this search. Future missions, like the Mars Sample Return mission, aim to bring Martian samples back to Earth for more detailed analysis. These samples, carefully collected from locations identified as potentially habitable in the past, could hold the key to answering the question, are we alone in the universe? Section 8. Mars and Humanity, a Future Among the Stars. Looking beyond scientific exploration, Mars represents a potential second home for humanity. Its resources, including water ice, could one day sustain human settlements. The challenges of living on Mars are significant, but the dream of becoming a multiplanetary species inspires us to overcome these obstacles. From developing advanced life support systems to creating sustainable habitats, the journey to Mars will push the boundaries of human ingenuity. It's a journey that will require global collaboration and a shared vision for the future of humanity among the stars. Section 9. The Red Planet Beckons. Mars, the once blue planet now cloaked in red dust, continues to beckon us with its mysteries and possibilities. It's a reminder of the dynamism of planets, the potential for life beyond Earth, and the boundless spirit of human exploration. As we continue to unravel its secrets, Mars reminds us that our journey to understand the universe and our place within it has only just begun.